last class, we have done all these things. We have done direction cosines, direction ratios, then some important deductions like direction, how to convert direction cosines into direction ratios. Then we have done the equation of a line space. Got it? Then we have done few questions over it. Then equation of line in space, how to write it in vector form, how to write it in 3D form. Then we understood how to find the point of intersection of two given lines. Yes or no? Then we did angle between two lines if their direction ratios are known. Angle between two lines if their direction cosines are known. So we have done all that. Now angle between two intersecting lines we also done. Even if lines are not intersecting, this is going to be the angle between them. Right? Then what happens if the lines are parallel? What happens if the lines are perpendicular? And so on, so forth. Got it? Then there comes skew lines. Got it? So today we will start with skew lines. So first of all, what are skew lines? Tell me. Skew lines are basically the lines which are neither parallel nor intersecting. Skew lines are the lines. So two straight lines in space which are neither parallel nor intersecting are called skew lines. Thus, skew lines are those lines which do not lie in the same plane. Got it? So they do not lie in the same plane. That is why even if they are not parallel, there is a situation that they are not intersecting also. This is like this situation. One line is going from above and other line is going from below. Got it? So what exactly do we do between skew lines? So if these are skew lines, like one line is this, other line is this. Now let us assume this is a line R is A plus lambda vector B. Means line is passing through point A with position vector A and it is along vector B. This is another line C plus mu vector D. Let it is passing through point C and it is along a vector D. Now you are trying to find the shortest distance between these lines. So first of all, shortest distance will be along the perpendicular. Or I should say, shortest distance will be along the vector which is perpendicular to both the lines. So first of all, we have to find a vector which is perpendicular to both the lines. Now, first line is along vector B, second line is along vector D. So their shortest distance will be along B cross D. Got it? Now, shortest distance between skew lines is what? Projection of AC on B cross D. And projection of AC on B cross D you are aware of, that is AC dot B cross D upon magnitude of B cross D. Am I clear? So that will be AC is what? C minus A dot B cross D upon magnitude of B cross D. And finally we take mod of this because why do we take mod of this? Because distance is always positive. Am I clear? Am I clear? So this is the formula for shortest distance between two lines. And to apply this formula, what do you require? You require 2 points, one on one line, other on other line, and two vectors along which line are lying. Or what do you want? Direction ratios of both the lines and points on both the lines. 1 point on the two lines. Got it? Now, write a question. See, this is the formula for shortest distance between the skew lines. All right. Now, this is the same formula in 3D form. You don't have to remember this formula specifically for 3D form. This is easiest in vector form. We will remember this formula in the vector form only. And a plus lambda b c plus mu d is c minus a dot b cross d upon magnitude of b cross d. And if lines will be coplanar, then this numerator of the shortest distance will go 0. So, to show that these two lines are coplanar, we need to show that this c minus a dot b cross d is 0. Got it? Now we'll do a question. So, first question is, find the equation of line passing through 1, 2, minus 1 and minus 1, 0, 1. Find the equation of line passing through 1, 2, minus 1 and minus 1, 0, 1 in both vector and 3D form. Got it? So equation of line in vector form will be, numerator में let's write x minus 1, y minus 2, z plus 1, minus 1 minus 1, 0 minus 2 upon 1 minus of minus 1. So this line is going to be x minus 1 upon minus 2 is y minus 2 upon minus 2 is z plus 1 upon 2. Got it? This is the equation of this line in vector form. 3D form. If you want to write it in vector form, it will be r equals to passing through this point. Position vector as I cap plus 2j cap minus k cap plus lambda times minus 2i cap minus 2j cap plus 2k cap. Got it? Second question. Find the equation of line passing through origin and parallel to the line x minus 1 upon 3, y minus 2 upon minus 2 is 2z minus 1 upon 4. Got it? Now we need to find the equation of line parallel to this line passing through origin. Now, if my required line is parallel to this line, if my required line is parallel to this line, they will be having same direction ratios. Yes or no? So now this line is, see, it can be rewritten as x minus 1 upon 3 1 minus 2 is, this is what I can write, z minus 1 by 2 upon 2. So direction ratios of this line are going to be 3 minus 2 and 2. Now in this case, line will be what? X upon 3 is y upon minus 2 is z upon 2. This is the second line. Am I clear? So in the vector form, this line can be written as 0i plus 0j plus 0k is 0. Directly mu times 3i cap minus 2j cap plus 2k cap. Got it? Now third part is Find the shortest distance. Find the shortest distance between two above lines. Find the shortest distance between two above lines. Now see, the first line was passing through 1, 2, minus 1, 1, 2, minus 1. It is along a vector minus 2 I cap minus 2 j cap plus 2 k cap. I can write it minus I cap minus j cap plus k cap. Now the second line is passing through 0, 0, 0, and it is along a vector 3 I cap minus 2 j cap plus 2 k cap. 3 I cap minus 2 j cap plus 2 k cap. Got it? Now, this is your A, this is your C. First of all, you want AC or CA vector. So I'm finding CA vector will be I cap plus 2j cap minus k cap. Got it? Then if it is your B vector, it is your D vector, then you want B cross D. That is determinant I cap, j cap, k cap, minus 1, minus 1, 1, 3, minus 2, 2. Got it? So it is with I cap minus 2 plus 2, it will become 0. With minus j cap, it will be minus 2 minus 3 minus 5, and with k cap it is 2 plus 3 5. So it became 5 j cap plus 5 k cap. Got it? Now shortest distance will be projection of AC or CA on B cross D, and find the magnitude of that. That is projection of I cap plus 2j cap minus k cap on j cap plus k cap. This vector. You don't have to write 5 here, because even if you write it, it will cancel out from the denominator. So that will be what? I cap plus 2j cap minus k cap dot j cap plus k cap upon magnitude of j cap plus k cap goes root 2. So your answer becomes 2 minus 1, 1 by root 2. So this is how we find the shortest distance between these two lines. Am I clear? Fine. Now, that's fine. Now see, if you have two parallel lines, say this is the line R equals to A plus lambda vector B, and this is the line R equals to some C plus mu vector B. R is A plus lambda vector B, other is C plus mu vector B. Now see, these are two parallel lines. That's pretty visible because they are both are along vector B. Yes or no? So these are two parallel lines. It's quite visible because they both are parallel to vector B. Now I want to find this distance. This is the shortest distance between these two. Now see, there is a point A, that is vector A. There is a point C, that is vector C. Got it? There is a point A which is vector A, point C which is vector C. Now you can find this joint AC. Vector AC will be C minus A. Got it? Now let us assume this vector is making angle theta with the vector B. So this is the perpendicular distance. Let this is H. So H is what? Magnitude of AC sine theta. And now AC cross B is magnitude of AC, magnitude of B sine theta. So you got sine theta as magnitude of AC cross B upon magnitude of AC magnitude of B. The magnitude of AC sine theta is magnitude of AC cross B upon magnitude of B. This is your H, shortest distance between these two parallel lines. Now you know how to write AC vector, you know how to find B vector. So you can find AC cross B. Then you can find the magnitude of AC cross B. Got it? And divided by sine theta. Got it? Have a look. Now, this is quite easy. So that is also the distance between parallel lines is C minus A cross B upon magnitude of B. Got it? Now, the condition of coplanarity is what? Do the shortest distance between them as 0. This is the condition of coplanarity of two lines is what? Do the shortest distance between them as 0. Correct? Now, equation of a plane. This is something that you have never studied. Equation of a plane. Equation of a plane. Now see, first of all, if we talk in the vector form, say this is a plane. This plane is normal to some vector n. And there is a point in the plane A with position vector as A. Now this much is given to me. There is a point in the plane normal to me and there is a normal vector of the plane given to me. Got it? So now to get the plane, to get plane, let us assume there is some point R into it. Got it? There is some point R into it. Now, what will happen? Since this n is a normal vector, can I say this AR vector is perpendicular to vector n? AR vector is perpendicular to vector n. That means R minus A dot vector n is going to be 0. So that means R dot n is A dot n. R dot n is A dot n. Am I clear? Have a look. So R dot n is A dot n. This is the equation of plane. Got it? So this is the equation of plane you are looking for in vector form. Now see, let us assume this normal vector given to you is this is ai cap plus bj cap plus ck cap. and this point A is x1 I cap plus y1 j cap plus z1 k cap.
Again, 12:24 to 25.
Hello. Yeah. So r dot n is a dot n. So r dot n will be ax plus by plus cz equals to a dot n means ax1 plus by1 plus cz1. Now this ax1 plus by1 plus cz1 is going to be some constant d. So equation of plane is ax plus by plus cz equals to d. Ax plus by plus cz is equals to d. So this is the equation of plane whose normal you are aware of. So that means this coefficient of x, a, coefficient of y, b, coefficient of z, c. The coefficient of x, y, z, they are the direction ratios of the normal of the plane. Coefficients of x, y, and z, they are the direction ratios of the normal of the plane. Am I clear? These coefficient of x, y, z are the direction ratios of the normal of the plane. So this is the very basic equation. Now see this. The general equation of a plane is ax plus by plus cz plus d equal to 0. And the general equation of the plane is ax plus by plus cz plus d equal to 0. And a square plus b square plus c square is not equal to 0. Where ABC are the direction ratios of the normal of the plane. Now, if ABC are the intercepts of the plane with the coordinate axis, then the equation is x upon a plus y upon b plus z upon c equals to 1. You must be aware that the intercept form of a straight line is what? X upon a plus y upon b equals to 1. Got it? Equation of the plane or to line in intercept form is x upon a plus y upon b equals to 1. So equation of the plane is x upon a plus y upon b plus z upon c equals to 1. Got it? So that is the plane with intersecting coordinate axis at a0, 0, 0, b0 and 0, 0, c. Now how did I get it? Now see, say there is a plane. This plane is passing through 3 points A, that is A0, 0 on the x-axis. Another point B, that is 0, B0 on the y-axis. Another point C, that is 0, 0, C on the z-axis. So to get the unique equation of a plane, what do you require first? You require the normal of the plane. Got it? Now in this plane, there are two vectors AB and AC are there. I can say AB, AC. So normal will be what? Since normal, it is the perpendicular to the plane, it is perpendicular to AB and AC also. So normal will be what? AB cross AC. So AB is what? AB will be minus AI cap plus BJ cap cross AC will be minus AI cap plus CK cap. So that is determinant I cap, J cap, K cap minus AB0 minus A0C. So with I cap, what do you have? BC With minus j cap, what do you have? Minus AC. And with k cap, what do you have? AB. So it is BC I cap plus AC J cap plus AB K cap. ठीक है? Got it? So equation of plane will be what? Equation of plane will be what? R minus A dot vector n is 0. Now R is what? Xi cap plus yj cap plus zk cap minus ai cap. Its dot product with bci cap plus acj cap plus abk cap is 0. Got it? So it will be x minus ai cap zk cap dot abk cap equals to 0. Am I clear? So it is BC times x minus a, CA y, ABZ equals to 0. So BCX plus CAY plus ABZ equals to ABC. Now if you divide it by ABC, you get x upon A plus y upon B plus z upon C equals to 1. Am I clear? Got it? Now see further. If L, M, N are direction cosines of the normal of the plane and P is the distance from origin of the plane, then the equation of plane is Lx plus My plus Nz equals to P. So what does it mean? That means this is the equation of a plane, say Ax plus By plus Cz equals to some D. Direction ratios are ABC. Now, if you convert these direction ratios ABC into direction cosine, and how to convert into direction cosine? Divide by magnitude, means make AI plus BJ plus CK as a unit vector. So A upon under root of A square plus B square plus C square into X, B upon under root of A square plus B square plus C square into Y, C upon under root of A square plus B square plus C square into Z will be D upon under root of A square plus B square plus C square. Now this A upon under root A square plus B square plus C square and so on, this became direction ratios. Direction cosine. So it will be Lx plus My plus Nz is equals to D upon under root of A square plus B square plus C square. D upon under root of A square plus B square plus C square. So if I convert them into the unit vector, means direction ratios, direction cosines. So the whatever I do have in the right hand side, it will be distance of this plane from the origin. Got it? So this property, this form is something like this. If L, M, and N are direction cosine of the normal of the plane and P is its distance from the origin, then the equation is Lx plus My plus Nz equals to P. Now, coordinates of put a perpendicular drawn from origin to the plane is this. This is okay. Got it? Now, these are various forms of the plane, but the only agenda, only target if you are trying to get the equation of a plane is what? Is what? You need a normal vector and you need a normal vector and you need a point in the plane. Am I clear? Now, let's do equation. Find the equation of a plane. Equation of a plane on which foot of perpendicular from origin is, find the equation of a plane on which foot of perpendicular from origin is alpha, beta, gamma. Find the equation of a plane on which foot of perpendicular from origin is alpha, beta, gamma. Now let us assume this is origin. Now this is a plane, and on this plane foot of perpendicular from origin is given to you as alpha, beta, gamma. That means this vector, this is the normal vector of the plane. So what will be the normal vector? Normal can be written as alpha I cap plus beta j cap plus gamma k cap. And there is a point also in the plane that you know, alpha, beta, gamma. So first of all, according to this normal vector, plane can be alpha x plus beta y plus gamma z equals to something. Yes or no? Now this plane is passing through alpha, beta, gamma. Plane passes through alpha, beta and gamma. So you get d as alpha square plus beta square plus gamma square. So equation of the plane is alpha x plus beta y plus gamma z is alpha square plus beta square plus gamma square. Am I clear? Now, have a look. Got it? Now, see another question. Find the image of point 1, 1, 1 in the plane 2x plus 3y plus 4z equals to 0. Got it? Now see, the question is, this is the plane given to you. There is a point P, say 1, 1, 1. You are trying to find the image of this point in the plane. Now image will be what? Image will be exactly opposite side of the plane at the same distance where point is lying. Got it? Now say this is the image P dash. Let us assume it is ABC. Now plane is given to me. Its normal is 2i cap plus 3j cap plus 4k cap. Let us assume this is the point Q, which is the foot of altitude from P on the plane. So how do we find the image with this information? You have a point and you have the equation of a plane. So How do I do it? First of all, find the equation of line PP dash. So this PP dash is the line passing through 1, 1, 1. It is along the normal of the plane. This PP dash is parallel to this line 2, 3 and 4. So it is x minus 1 upon 2 is y minus 1 upon 3 is z minus 1 upon 4. X minus 1 upon 2 is y minus 1 upon 3 is z minus 1 upon 4. This is the equation of PP dash. Now I have to find the point Q. Q is what? Q is the point of intersection of this line and the plane. Now let us take a random point on the line. A point on the line is 2 lambda plus 1, 3 lambda plus 1, 4 lambda plus 1, correct? Now for different values of lambda, you will keep on getting different points. You want the point which is lying in this plane so that we can get Q. Put this point in the plane. Got it? So if I do, so I get twice of 2 lambda plus 1 plus thrice of 3 lambda plus 1 plus 4 times of 4 lambda plus 1 equals to 0. So you get 4 lambda plus 9 lambda plus 16 lambda is 4 and 3, 7 into 9 minus 9. So lambda came minus 9 upon 29. With this value of lambda, I actually got point Q. So Q is what? Q is 2 lambda plus 1. So 1 minus 18 upon 29. 1 minus 27 upon 29. And 1 minus 36 upon 29. Got it? So what is your Q finally? 29 minus 18, that is 11 upon 29, 2 upon 29 and minus 7 upon 29. Now see, since P dash is the image of P, this point Q is going to be the midpoint of PP dash. Q is midpoint of PP dash. So 1 plus A upon 2 is 11 upon 29. 1 plus B upon 2 is 2 upon 29. And 1 plus C upon 2 is minus 7 upon 29. Got it? So what is your A? 22 upon 29 minus 1. What is your B? 4 upon 29 minus 1. And what is your C? Minus 14 upon 29 minus 1. Got it? So finally, ABC, which is the image point, is going to be minus 7 upon 29, minus 25 upon 29, and minus of 43 upon 29. This is your image point. Clear? I hope I have made my point very clear. So this is how we find the image of a point into a plane. Alright. Now some results about important about the plane. If theta be the angle between two planes. See, first of all, acute angle between two planes is actually the acute angle between its normals. Am I clear? Acute angle between two planes is actually the acute angle between its normals. So one normal is along A1, B1, C1, other normal is along A2, B2, C2. So what is the angle between them is cos inverse of A1, A2 plus B1, B2 plus C1, C2. That is angle between normal vectors upon under root of A1 square plus B1 square plus C1 square under root of A2 square plus B2 square plus CT square. This is basically the angle between A vector that is A1 I cap plus B1 j cap plus C1 k cap, and B vector that is A2 I cap plus B2 j cap plus C2 k cap. Got it? Now, if two planes are parallel, if their normals are parallel, and the planes are perpendicular, if their normals are perpendicular, but obviously. So, if R dot N1 is D1, R dot N2 is D2, are two planes, then they are parallel if N1 is lambda N2. Means A1 upon A2 is B1 upon B2 is C1 upon C2. And they will be perpendicular if N1 dot N2 goes 0. Means A1 A2 plus B1 B2 plus C1 C2 is 0. Like a simple question, if I write, find lambda and mu if two planes, 2x minus 3y plus 4z equals to 11 and 8x minus lambda y plus mu z equals to 7 are parallel. So if these two planes are parallel, that means 2 by 8 A1 upon A2 is B1 upon B2 3 by lambda is C1 upon C2 4 by mu. So 1 by 4 is 3 upon lambda is 4 upon mu. So what is lambda? Lambda goes 12. What is mu? Mu goes 60. So if you put these values of lambda and mu, you will get the planes parallel. Am I clear? Got it? Now, distance of a point x1, y1, z1 from the plane ax plus by plus cz plus d equal to 0. This formula is exactly like the formula of distance of a point from a line. Ax1 plus by1 plus c upon under root of a square plus b square. Here this cz1 comes extra and this c square comes extra. Rest everything is almost same. Got it? So distance of a point x1, y1, z1 from the plane ax plus by plus cz plus d equal to 0 is ax1 plus by1 plus cz1 plus d upon under root of a square plus b square plus c square. Now distance of origin means x1, y1, z1 is 0. So d upon under root of a square plus b square plus c square. So this is what distance of a point from the plane. Now distance between two parallel planes is ax plus by plus cz plus d1 equal to 0 and ax plus by plus cz plus d2 equal to 0. So this distance is going to be d1 minus d2 upon under root of a square plus b square plus c square. d1 minus d2 upon under root of a square plus b square plus c square. Remember one thing, while applying this formula, either both d1 and d2 should be on the right side of equality or both should be on the left side of equality. Don't use it one on the left side and other on the right side. Got it? Like a simple example, if I ask you, find the distance between two planes 2x plus 3y minus 4z equals to 7 and 4x plus 6y minus 8z minus 2 equals to 0. Now, what precaution should one take to find the distance between these two planes? First of all, these two planes are parallel that we can judge using the proportionality. You see coefficient of x ka ratio 1 by 2, ratio of the coefficient of y 3 by 6 1 by 2, ratio of coefficient of z minus 4 upon minus 8 1 by 2. Got it? So, first of all, do something like this ratio goes 1 1. So either multiply first plane by 2 or multiply the second plane by 1 by 2. So I do the otherwise. So it is 2x plus 3y minus 4z equals to 7. Other plane is 2x plus 6y, 2x plus 3y minus 4z equals to. Now see, I am going to take this 2 to the right side. 1 after dividing by 2. Because I told you while applying the distance formula, either both constants should be on the right side of equality or should be on the left side of equality. So distance between them is 7 minus 1 upon under root of a square 4, b square 9, c square 16. So magnitude of this. So it is 6 upon root 29. Got it? 6 upon root 29 is the distance between these two parallel planes. Got it? Distance between two parallel planes. Now, angle between a plane and a line. Now see, this is a line given to you. X minus x1 upon A is y minus y1 upon B is z minus z1 upon C. And there is a plane A1x plus B1y plus C1z equals to D1 AD. Now they are saying angle between this line and this plane is theta. Now see, if this is a plane and there is a line, somehow if they are saying angle between this line and the plane is theta, that means angle between normal of the plane and the line is going to be 90 minus theta. So we will use this 90 minus theta to get the angle between line and the normal of the plane. So cos 90 minus theta will be AA1 plus BB1 plus C upon this. Now from this you get sin theta. And we get theta from this. Either a standard angle it can be or it can be sine inverse of something. Got it? Now, if line and plane are perpendicular, that means line and normal of the plane are parallel. So if line and normal of the plane are parallel, that means A by A1 is B by B1 is C by C1. Got it? Then, if AA1 plus BB1 plus CC1 goes 0, then line is parallel to the plane because in this case, normal will go perpendicular to the plane. Got it? Now, there is a formula for foot of perpendicular which I do not recommend you guys can remember. So better if it is, we have to find it. Then we will find the foot of altitude like I did the image question. Got it? Now, rest of the thing is equation of angle bisector of a plane will do in the next class because this is going to be really heavy for you and we will also practice certain questions in the next class also. All right. So that would be all from my side for today and just a small feedback, please.